There's a grass that the World Bank has spent over $100 million planting across 120 countries. It survives temperatures from minus 15 to 55 degrees Celsius. Its roots grow 13 feet deep in 1 year. It filters arsenic, lead, and mercury from contaminated water. It stops soil erosion on slopes that concrete walls can't hold, and you have never heard of it, because it costs about $10 per plant. And no corporation can profit from a grass that solves problems for free. Its roots grow 13 feet deep in a single year. 13 feet. That is deeper than most trees reach in a decade. Deeper than the foundation of a 2-story house. Deeper than the water table in half the dry regions on Earth. It survives temperatures from minus 15 degrees Celsius to plus 55 degrees Celsius, from Siberian frost to Saharan furnace. One single plant, same species, no modification, no greenhouse, no irrigation. It filters arsenic from contaminated water. It pulls lead out of poisoned soil. It absorbs mercury, chromium, zinc, and nickel from industrial runoff. Not with a machine, not with a chemical process, with its roots. It stops landslides on slopes so steep that concrete retaining walls collapse. It holds highway embankments that sheet pile walls cannot. And it does this at 70 to 95% less cost than engineered structures. And here's the part that should make you angry. You can grow it for less than $1 per meter of hedge. In developing countries, the World Bank documented costs as low as $5 to $20 per hectare. Per hectare. That is 2.5 acres of erosion protection for the price of a fast food meal. And you have never heard of it. You have never seen it in a hardware store, never seen it advertised, never seen a single commercial for it. Because no corporation can build a recurring revenue model around a grass that never dies, never needs replanting, and solves problems that entire industries charge billions to fix. This grass is called vetiver. And this is the story the building industry, the water treatment industry, and the erosion control industry would prefer you never heard. Let us start underground. Because that is where vetiver does things that engineers still cannot fully explain. Most lawn grasses grow roots 6 to 12 inches deep. Bermuda grass, one of the deeper ones, reaches about 6 feet in ideal conditions over several years. And vetiver reaches 13 feet in its first year. That is 4 meters straight down. And these are not ordinary roots. Vetiver roots have a tensile strength of 40 to 120 megapascals. For comparison, mild steel has a tensile strength of about 400 megapascals. So vetiver roots are between 1/10 and 1/3 the strength of steel. Except they are alive. They grow. They regenerate. They grip soil particles at a microscopic level that no synthetic material can replicate. When these roots penetrate soil, they create a living reinforcement matrix. The same principle as rebar inside concrete, except the rebar grows itself, repairs itself, and costs almost nothing. This is why vetiver can stabilize slopes of up to 75% incline. That is a slope so steep, most people cannot walk up it. Concrete gravity walls on that angle need massive foundations and cost thousands of dollars per linear meter. Vetiver hedges on that same slope cost $5 to $20 per hectare. In China, highway departments tested vetiver on road embankments that had failed repeatedly, despite concrete reinforcement. After planting, erosion dropped by over 90%. The embankments held. The cost was a fraction of the concrete that had already failed. In Ethiopia, hillsides that had been losing topsoil for generations were stabilized within 2 growing seasons. Crop yields on the terraces behind the vetiver. Hedges increased because the soil stopped washing away. The World Bank documented all of this. Technical paper number 273, published in 1995, edited by a man named Richard Grimshaw. He spent decades proving this grass works. The data is public. The results are overwhelming. And almost nobody has read it. Now consider what this grass survives. Vetiver has been documented growing in regions where winter temperatures drop to minus 14 to minus 15 degrees Celsius. The tops of the grass die back. The crowns go dormant. And when spring arrives, it regrows from the base as if nothing happened. At the other extreme, vetiver thrives in regions where temperatures exceed 55 degrees Celsius at ground level. The Arabian Peninsula, Central Australia, the Sahel, places where most plants cannot survive without constant irrigation. It tolerates drought because those 13-foot roots reach moisture that surface plants never access. It tolerates flooding because it's dense. The crown can survive submersion. It has been documented growing in soil with pH ranging from 3.3 to 12.5. That is everything from strongly acidic mine drainage to alkaline industrial waste. It tolerates salinity. It tolerates heavy clay. It tolerates pure sand. It tolerates laterite, which is the rock-hard tropical soil that most plants cannot penetrate. And here is the critical detail. The cultivar used worldwide is sterile. It does not produce viable seeds. It can only spread through root division, which means a human has to physically separate the plant and replant it. It cannot become invasive. It cannot escape into ecosystems and take over. This was engineered deliberately so that governments and farmers could plant it without ecological risk. A grass that survives almost any temperature, grows in almost any soil, cannot become invasive, costs nearly nothing, and cleans water. Which brings us to the part that should genuinely alarm you. There are places on Earth where the water is poisoned, not metaphorically, literally. Mining operations leave behind tailings ponds laced with arsenic. Factories discharge chromium and lead into rivers. Smelters contaminate groundwater with mercury and cadmium. The conventional solution is chemical treatment plants, costing millions of dollars to build and thousands per month to operate. Vetiver does it with roots. Research published on PubMed and through multiple peer-reviewed studies shows that vetiver absorbs heavy metals directly through its root system. The plant pulls nickel at 38% removal efficiency, zinc at 35%, chromium at 28%. And arsenic accumulation has been documented at significant concentrations in root tissue. A study indexed on Science Direct by Banerjee in 2016 confirmed that vetiver can stabilize arsenic, lead, and mercury in contaminated water and soil simultaneously. This is called phytoremediation, using living plants to clean pollution. And vetiver is one of the most effective phytoremediation species ever documented. In Australia, vetiver was planted around mine sites to prevent contaminated runoff from reaching waterways. It worked. In Thailand, vetiver hedges were used to filter wastewater from shrimp farms. Pollutant levels dropped dramatically. Now, think about this. A chemical water treatment plant for heavy metals costs $2 to $10 million to build. Annual operating costs run into the hundreds of thousands. Sludge disposal adds more. Permits, monitoring, compliance, staff, vetiver hedges. For the same site cost a few $100s, maybe a few thousand for a large installation. No electricity, no chemicals, no staff, no sludge. The plant does the work. The roots hold the metals. The clean water passes through. And when the vetiver eventually reaches end of life in that application, the biomass can be harvested and processed. The metals are concentrated in the plant tissue rather than spread across an entire watershed. This is not experimental. This is documented across dozens of countries. The World Bank funded it, universities proved it, governments deployed it. And the water treatment industry is worth over $300 billion globally. $300 billion. Sold to you one chemical treatment at a time. Let us talk about what holds the ground beneath your feet. Every year, landslides destroy roads, homes, and farmland across the developing world. The standard engineering response is a concrete retaining wall, a gabion basket, a sheet pile barrier. These cost anywhere from $200 to $2,000 per linear meter, depending on the height and soil conditions. Vetiver hedges cost 70 to 95% less. A cost comparison study documented by the Vetiver Network showed that vetiver hedges provided equivalent or superior slope protection at a fraction of the price. On steep highway cuts in China, vetiver outperformed concrete, structures that had already cracked and failed. Why does this work? Because the problem with slopes is not surface erosion alone. The problem is deep soil movement. Concrete walls resist surface pressure, but they are rigid. When the soil behind them shifts, the wall cracks. When water builds up behind the wall, hydrostatic pressure pushes it outward. The wall fails catastrophically. Vetiver works differently. The roots penetrate deep into the failure plane of the slope. They bind the soil internally, not externally. Water moves through the vetiver hedge freely, so there's no pressure buildup. The roots flex with minor soil movement rather than cracking. And because the roots grow continuously, the stabilization actually improves over time instead of degrading. In one documented case, a stretch of road in a mountainous region had required concrete retaining wall repairs 3 times in 10 years. Each repair cost tens of thousands of dollars. Vetiver was planted as a test. 10 years later, no further repairs were needed. The global erosion control market is worth over $4 billion annually. It is dominated by companies selling concrete, geotextiles, steel mesh, and chemical soil binders. All of them are consumable. All of them degrade. All of them need replacement. Vetiver is alive. It does not degrade. It grows stronger. And you cannot sell a replacement for something that never breaks. So let us ask the obvious question. If this grass does everything we just described, and it has been proven for decades, and the World Bank itself funded it, why is it not everywhere? The answer is economics, not the economics of vetiver. The economics of every industry it threatens. The global flooring and construction materials market exceeds $400 billion. The water treatment market exceeds $300 billion. Erosion control is another $4 billion. Chemical fertilizer is over $200 billion. Vetiver threatens pieces of all of them. You cannot patent a grass. You cannot create a proprietary version. The sterile cultivar was deliberately made open source by researchers who believed it should belong to everyone. No licensing fees. No royalty payments, no intellectual property protection. This means no venture capital funding, no corporate marketing budget. No lobbyists in government halls, no trade association running ad campaigns. Think about what gets advertised to you. Chemical fertilizers, engineered retaining walls, water purification systems with replaceable filters you buy every 3 months, concrete, asphalt, synthetic turf. Every single one of those is a product designed to be purchased, consumed, and purchased again. That is the business model. Recurring revenue, planned degradation. Vetiver does not fit that model. You buy it once, you plant it once. It grows forever. It does not generate shareholder value because it does not generate repeat customers. Richard Grimshaw, the man who spent decades championing vetiver at the World Bank, described the challenge simply. He said the biggest obstacle was never the science. The science was overwhelming. The biggest obstacle was that no one could make money from it at scale. A solution that costs nothing recurring is invisible in a market that runs on recurring costs. So here is what you can actually do. Step 1. Source vetiver slips. In tropical and subtropical regions, agricultural extension offices often distribute them at low cost. In developed countries, nurseries sell bare root slips. Prices range from a few dollars retail, but if you buy in bulk or connect with vetiver network groups, costs drop dramatically. In large-scale projects in developing nations, costs have been documented at $5 to $20 per hectare. Step 2, plant in a row. Vetiver is planted as a hedge, not scattered randomly. Space the slips 10 to 15 centimeters apart in a line along the contour of the slope or the edge of the area you want to protect. Within 1 to 2 growing seasons, the plants merge into a continuous, dense hedge. Step 3, water during establishment only. Once established, vetiver does not need irrigation. Its roots will find water no matter how dry the surface becomes. Step 4, do nothing. That is not a joke. Once vetiver is established, there is no maintenance required. You can trim the tops if you want to use the leaves as mulch, animal feed, or thatching material. But the plant itself needs nothing from you. Within 1 year, those roots are 13 feet deep. Within 2 years, the hedge is a solid wall of erosion protection, water filtration, and slope stabilization. It will survive drought, flood, frost, and extreme heat. It will outlast every concrete wall, every gabion basket, and every chemical treatment system built beside it. The World Bank proved this works. Over $100 million in research and deployment across 120 countries. Peer-reviewed studies in dozens of journals. Field results spanning decades. A grass that cleans water, holds mountains, survives everything, costs almost nothing, and belongs to no one. You now know about it. What you do with that knowledge is up to you.